Hello dear friend, this is Himmet CAN. Now we continue our lecture in this lecture, which is lecture 8. We consider the application of integration area between curves. Actually, we deal with the special case, which is the areas in the Cartesian coordinate system. Okay, now the first definition is I. As you can see that we have an area A here, and we have two curves F and G, and the lines A and B, and then the area A of the region bounded by the curve F and G, and the line A and B is defined by A is the integral from A to B, the absolute value of F minus G dx. Okay, now as you can see that here we have actually two functions F and G. Now maybe we can have just one function at that time. Our definition is the special case of the definition I, which is the area A of the region bounded by the curve F and the lines A and B, and x-axis is denoted by that A is equal to from integral from A to B absolute value of f of x dx. As you can see that here we have just one function. Okay, now if you look at carefully these two definition, you can see that everything depends on the variable x. The function depends on variable x, and our the limit of the integration again depends on the x. For example, x is equal to a, x is equal to b. Now similarly, we can give the same definition in terms of the variable y, that is I dash actually correspond to the I, which is the area A of the region bounded by the curve x is equal to h of y, x is equal to k of y, and the line C and D is given by that A is the integral from C to D absolute value of h minus k dy. Okay, now the special case of the I dash is given by double I dash, which is the area A. You can see that the area A is given by like this, the area of the region bounded by the curve H and the line C and D, and y-axis is denoted that A, the integral from C to D absolute value of h dy. Okay. Now here, as you can see that, as you can consider carefully everything, here everything depends on the variable y. Okay, the function depends on y, and the limits of the integration again depends of the y. For example, y is c and y is d. Okay, now I would like to explain this theoretical definition by giving three examples. Our first example is example 1. Please find the area of the region bounded by x is equal to, y is equal to x cube, and the line x is -1 and x is 1 and x axis. Okay. The solution of this question can be like this. Now, let's look at here. As you can see that our curve is y is x cube, say function f. Okay, the integration limits x is -1 and x is 1 and x axis. Okay, if we use this definition, our area is from -1 to the 1 absolute value of f of x dx. Now let's write the area A from integral from -1 to 1 absolute value of x cube dx. Okay, now this is our function f. Now we need to solve this integral. As you can see that we have absolute value, and then we have to remove that absolute value. So we first need to root of x cube, then x is 0. The second step is we need to sign table of x cube. This is our integration limits, and the root of x cube is 0, and so the sign of the x cube is 1. 1 is positive, and so plus and minus. Okay, now I think we can write, as you can see that inside the sign of the inside of the absolute value is minus, and so we need to divide this integral two parts. The integral from -1 to 0 plus 0 to 1. Okay, -1 inside is inside of the absolute value is negative, and so let's put here minus x cubed dx plus integral from 0 to 1. Here the sign of the absolute inside of the absolute value is positive, and x cube must be positive dx. Okay, now we can calculate easily this integral, because x cube is a polynomial, and so x to the 4 over 4 minus 1 to 0 plus x to the 4 over 4 from 0 to 1. Okay. If we calculate, let's put firstly 0 instead of x to the 4, and so we have 0, and then minus comes from definition 1 over 4 plus 1 over 4 minus 0. Okay, minus minus 1 over 4 plus 1 over 4. Okay, 1 over 2 square units. Square units. The area is half square units. Okay, now as you can see that I don't draw the graph of the given function. Now we can ask ourselves the graph of the function. Let's draw the area and the graph of the given function. Okay. The graph of x cube is given like this, and so minus 1 and 1, and here is the origin point. The area is the drawn area. Okay, right. As you can see that after the calculation of the area, and then I draw the graph. I am saying that actually we don't need to such a graph. Okay, we don't need to such a graph because maybe you cannot draw the given curve. This means that I am saying that here we don't need to draw the given curve and area. Okay, if we use our main definition, we can actually calculate the area of given function. The second question or example is calculate the area of the region bounded by the curve y is ln of x and line y is 0 and y is 1 and y axis. Okay, the The solution is that y is ln of x. This is our curve or function, and the limit of the integration is 0 and y is 1 and y-axis. Okay, now as you can see that y is 0 and y is 1, we cannot change this variable and y-axis. So as I said before, everything must be depends on the y, but our function is, as you can see, that depends on at the moment x, and so we can change the variable, which is x is equal to e to the y. Okay, now as you can see that everything is ready, and we can calculate the given area A. Area A is that the integral from 0 to 1 absolute value of e to the y dy. As you can see that this is the exponential function. This is always positive, and so integral from 0 to 1 e to the y dy. All right. The integral e to the y is e to the y from 0 to 1 and e minus e to the 0 is 1 square units. The area is square e minus 1 square units. Okay, now again as you can see that we can calculate the area without drawing the graph of the curve, and now we can draw the given curve like this, because one wants to see that the area, where is the area. Okay, now this is our function ln of x, means that x is e to the y. This is our lower limit, and this is our upper limit 1, and so this is our x-axis. The area is here. Okay, right. The last example is example 3. Find the area of the region enclosed by the curve x cube and x. As you can see that here we have two function or two curve. Y is x cube, y is x. Let's call x cube as f. Let's call x as g. Okay, now the area is integral absolute value of x minus g dx. Okay, what is x? What is f? X cube minus x dx. Right. Now, firstly, we have to find the root of x cube minus x, and so that x cubed minus x is 0, and then x times x square minus 1 is 0. At that time, the roots is this polynomial. First root is 0, second and third root is minus plus 1. Okay. Now, as you can see that we have three roots, minus 1, 1, and 0. As you can see that we didn't write the upper limit and lower limit and upper limit, and then actually here the limit of the integration doesn't give in this question, and so now we can write the limit of integration. How can we write the limit of integration? The answer is, please find the roots of the inside of the absolute value. After that, least root your is lower limit. Let's write here minus 1, and greatest number is your upper limit. Okay, and then now we have the limits of the integration, that which means that everything is okay. And so the second step is we have to consider the sign table of this polynomial, which is x cubed minus x. Our roots are minus 1 and 0 and 1. If you look at carefully this polynomial, the sign of x cubed is 1, which means that's positive, and then plus, minus, plus, and minus. Okay. Our integral is given from minus 1 to 1, and so we have to consider here as you can see that we have to divide this integral two part, the integral from minus 1 to 0 plus from 0 to 1. Okay, let's write. Here you can see that the inside of the absolute value is positive, and so minus 1, 0, x cubed minus x dx plus 0 to 1. The absolute value of absolute, the sign of the absolute value inside, the sign of the inside of absolute value here, you can see that minus, and so let's put minus x cubed minus dx. Okay, now if you calculate these two integral, and then you will find that half square units. This is your area. Okay, now I think we can draw our given 2 curve x cube. And what is x? Okay, the area is here. Okay, minus 1, 0, and 1. As you can see that we have two parts of the area. This is our first part. This is our second part. Okay, thank you.